right, let's see. I would solve this one up in the following fashion. I draw a triangle A, B, C. From the similarity statement, triangle D, E, F should be constructed like this. AB is 20, BC is 18, DF is 10, and DE is 8. From this information and this scale and this similarity statement, therefore we need to know what side length EF is and what AC is. So I call them X and Y. You don't have to do that, but I did. So then let's see, I said 20 over 8 is equal to 18 over X. 20 over 8 is 18 over X. Cross multiply and you get 20X is equal to 144, or X is equal to 7.2. Side length EF is 7.2. Same game with AC. You can say, again, 20 over 8 is Y over 10. 200 equals 8Y. Y is therefore 25. Scale factor should be the value that you multiply triangle any length in triangle ABC to get to the corresponding length in DEF. So if you said that the scale factor is 20 over 8, which reduces to 5 over 2, you're telling me that you could multiply 20 by 2.5 and get a length of 8, which is not true. Multiply 20 by 2.5, you get what? 50, which is significantly different than 8. That is how the book defines scale factor. If you're going by the book's definition of scale factor, which would be 5 over 2, you're not creating a useful quantity. We defined it as the reciprocal of that, or in this case, 8 over 20, which is 2/5. That's useful because I could take 20, multiply it by 2 over 5, and get exactly 8, the corresponding side length. You can think of this as taking the length in the, this would be the length in the image, let's say, and divide it by a corresponding length in the pre-image, is what we end up getting. Okay. If you use this manner to define scale factor, you're gonna, what's nice is that if you've been doing it up to this point, then your definition is not going to have to change for finding a scale factor and for finding a scalar multiplication. All that stuff works together in harmony. If you don't, then, well, it's not going to be, you're going to have to learn 2 different rules. Okay, as we said, a dilation is any transformation that's more or less, we're going to like zoom in or zoom out based on a certain point. Okay? Dilations change the size of an object by a scale factor. Okay? So looking at these 2 drawings, in the first one, is this implying, is this dilation, this change in size, going to be an enlargement or a reduction? Okay. If you think it's if we think it's a reduction, why is it a reduction? It looks like it's getting bigger. Christine? Well, the big one has just P, but this one is P prime. So by the notation, this is saying that we're going from pre-image to image. Absolutely. So this is certainly a reduction. And what's the scale factor of this reduction? How about as a fraction? 1/3? 2/3. 0.6 repeating 2/3. Again, we can get the scale factor by taking the image and dividing it by the pre-image, which in this case gives us 10 over 15, which is a scale factor of 2/3. Meaning, check your work, you can take the original 15, multiply it by 2/3, and get the image. 15 times 2/3 is exactly 10. Say again, find these, tell whether it's a reduction or enlargement, and then find the scale factor as quick as you can. Getting larger. And it's getting larger by the image is 15, pre-image was 6. Which is 5/2. Scalar multiplication on a matrix, since we tend to represent these objects. Folks, I do not want to talk over topic. To perform a dilation, the easiest way is to write your object as a matrix and then perform scalar multiplication, or multiply every element of a matrix by a given constant. A constant being a number, a real number. In this case, we're working the real number system, so it would be real numbers. That number is called a scalar. It's called a scalar because it scales the size by a given quantity. Your scalar, if you want to perform a dilation, will be just the scale factor, the rule that transforms from the start to the finish. So if we've been writing scale factors in this fashion, then all we need to do is multiply, write your thing as a matrix, and multiply it by that given quantity. So for example, this matrix would be an example of, say, a triangle, 3 points, that's being scaled or dilated by a factor of 7. So if I want to perform this scalar multiplication, I'll just take every element in this matrix and multiply it by the scalar in front, by 7. 14, -7, 35, 21, 28, -14. Example is vertices of this quadrilateral x, y, z, w are given. Use scalar multiplication to find the image after this dilation, with its at the origin and the scale factor of 1/2. Then graph both, the image and the pre-image. First, let's write our quadrilateral as a 2x4 matrix. We'll represent our quadrilateral as a matrix. We're gonna we want the scale factor to be 1/2, so we'll multiply this matrix by 1/2 to get the image matrix. X prime, Y prime, Z prime, W prime. And our image matrix should be 1/2 times each of those, which is half of each. -2, 2, 1, 4, 3, 1, -1, -2. Is the image matrix. Graph all those points. Finish this problem by graphing each of these two quadrilaterals, and then work on the last one. X. Your last one, let's perform the translation.
Didn't do anything.
If I bend this out hard enough, I can form a hook.
So for the final one, you should get matrices looking like this. Your final should be -3, -3, 0, 3.
Make something special.